Hello. In this video, we're going to be looking at number systems. Now, the first number system you probably learned was the natural numbers. These numbers are called natural numbers because they arise naturally. 1, 2, 3, what could be more natural than counting? And we write them with this fancy n. Now, after a while, humans decided that we wanted to add some more numbers, and so we expanded our number system. For example, we added 0, a big accomplishment that took a few thousand years, and we created the whole numbers, written with a W. After, again, some more argument and some more insight, mathematicians decided that the negative numbers were also numbers, and together they make the integers. These are both negative and positive numbers. Now, this took a few hundred years for mathematicians to fully accept because you could imagine having, let's say, 3 sheep, but it's hard to imagine having negative 3 sheep. What does that represent in the real world? And so it took a while for these integers really to take hold, but eventually they gained acceptance, and we write them with this fancy Z. Now, there are some other numbers we know. Q stands for the rational numbers. Q, of course, being quotient, and these numbers come to us from the ancient Greeks. They're the idea of taking a number and writing it as a fraction, a over b, where a and b are both integers, and of course b cannot be 0, because you can't divide by 0. And then there were other numbers as well that didn't quite fit the rationals. We also have the ancient Greeks to thank for this. Irrational numbers consist of numbers that cannot be put in the form of a fraction, a over b. And so, for example, the square root of 2 is a classic irrational number, as is pi, and many others. Now, when you take all the rationals and all the irrationals together and you union them together, you get the real numbers. And so these are the numbers that we've mostly been studying in our course. The real number system, which has the naturals and the wholes and the integers and the rationals and the irrationals all put together to make the wonderful real number system. Now let's practice categorizing numbers. Say we look at the number 2. Is this natural, whole, integer, rational, irrational, real? Which one does it meet the criteria for? Now, 2 is definitely a natural number because it's one of the counting numbers. 1, 2, 3, and so on. It's also a whole number, and it's also an integer. Now you might think to yourself, oh, it doesn't look like a fraction. Maybe it's not a rational number. But you can always take a number and put it over 1. So 2 over 1 makes it a fraction, and so it is indeed a rational number. Now you can't be both rational and irrational at the same time, so it's definitely not irrational, but it is a real number. Let's try negative root 17. Well, square root of 17, it doesn't square root nicely. And so, first off, it's not natural because it's negative, it's not whole. It's not going to be an integer. It's not going to be a rational number. In fact, this is an irrational number, which is still, of course, real. Now, take a look at this one, 9 over negative 37. Again, not natural, not whole. It's not an integer, but it is a rational number, and it is real. Go ahead and pause the video and try the next few. See if you can categorize them as rational or irrational. So I'm assuming you gave it a try, and let's go through some of these. So 0 is not natural, but it is whole, integer. It is irrational because you can put it over 1. It's not irrational, and it is real. Now negative 6.06, well, you could put it over 1 to make it a rational number, but to be a rational number, you have to be an integer over an integer, and the number here is not an integer. But what you can do is multiply the top and the bottom by 100, and that will give you negative 606 over 100. And that proves that it's definitely a rational number, which makes it real. Now 4.56 repeating. If you have the Mr. Peters approved calculator, you can actually type this in. You have to hit the alpha button, and then you have to hit the button where the square root is, because over top of that you should see a little box with a line on top of it, and that means repeating. So you can type in 4.56 repeating, hit equals, and see what you get. So the calculator should give 137 over 30. Now, if you don't have the Mr. Peters approved calculator, you can check 137 divided by 30 will give 4.56 repeating. And so that's a neat little trick. You can use your calculator to actually figure out what fraction gives a repeating decimal. And so it is a rational number, which makes it also real. Now let's look at the next set here. The 3.05.005.0005, it has a pattern to it, but the pattern is not repeating. And because it doesn't repeat, that makes it irrational, but of course still real. Similarly, pi, as a decimal, it will continue on and on and on, and it will never repeat, which makes it a famous irrational number, and also real. Now this one here, you might be tempted to say it's a rational number because it's a fraction, but the bottom can't be 0. In fact, if you have a number like this, well, this isn't even real. This is not a real number. This isn't rational, it's not irrational, it's not even real. This is not part of our number system. You could make up a type of mathematics where this was a number, but for our purposes, it is not a real number, and in many sense, it's not even a number. We would say it's undefined. Undefined. Now, pi over 4, this is tempting to say, oh, it looks like it's going to be a rational number because it's a fraction. But the top of it has to be an integer. And here, this is not an integer. And so because the top is not an integer, it makes it irrational and real. So continuing on here, 0.634 repeating. If you check on the Mr. Peters approved calculator, you can definitely find a fraction for this. It should be 634 over 999, which makes it rational and real. Square root of 225, you might be tempted to say is irrational because of the square root. But if you actually square root it, you'll just find the number is 15. So because this simplifies to 15, well, that's a whole number, and a natural number, and an integer, and a rational, and a real. 0.634 will be rational and real because you could write it as 634 over 1,000. Root 4 over 49 would be square root 4 over square root 49, which becomes 2 over 7, definitely rational and real. And finally, negative root 64 will be negative 8, which is not whole, but it is an integer, it is rational, and it is real. Now, a few things to note about decimals and fractions. Another way to think about a rational number is that its decimal expansion either terminates, which means stops, or it repeats. So you can try typing in 7 over 8 on your calculator and see what you get as a decimal representation. You should be getting 0.875. Notice how that stops. That's because it's a rational number. And 2 over 3, well, it doesn't stop. It gives you 0.6 repeating. So in both cases, we have a decimal that stops or a decimal that repeats, which is another way of saying we have a rational number. The opposite, of course, would be a decimal that never stops and never repeats, like 3.1415296535 and all of these numbers will continue in its decimal representation. Because it never stops, because it never repeats, that's what makes pi an irrational number. Now, there are an infinite type of each number. So, for example, the natural numbers, well, they start at 1, and they go 2, 3, but then we put a little ... because the natural numbers continue on forever. And so it's interesting that there are an infinite number of natural numbers, or there's an infinite number of maybe irrational numbers, an infinite number of whole numbers, an infinite number of integers. It's just interesting that each type of number has an infinite number of them. Now, another thing that's interesting here is that between every two rational numbers is another rational number. This isn't true for integers. So just as an aside here, if you take the integers, let's say 5 and 10, sure, you can find a number in between them, maybe the number 6. But if you try to say, oh, I'm going to look between 5 and 6, is there an integer between those? Well, I can't find one. There's no integer between 5 and 6. But if you look at, let's say, the fraction 1/2 and 1/3, you can always find a number between 1/2 and 1/3. It might take a little bit of problem solving, a little bit of time. I encourage you to pause the video and think of how you might find a number between 1/2 and 1/3. All right, assuming you gave it a try, we could multiply both of these fractions to boost them up a bit. Maybe we'll multiply this one by 30, and maybe we'll multiply this one by 20. Well, that'll give me 30 over 60, and that'll give me 20 over 60. Well, that's really clear. We could pick maybe 25 over 60, and that'll be between those two. So anytime you find two rational numbers, you can always boost them up a little bit, and then you'll be able to find a new rational number between those, and another one between those, and so on and so forth forever. No matter what fractions you come up with, no matter how big or how small, you'll always be able to find another fraction hidden in between. Now, that's also true for real numbers, and it might be a bit easier to see with the decimals. If I said 1.2 and 1.3, well, there's clearly a number between those two. You would just add another decimal place, 1.25 maybe. And of course, there are numbers beyond the real numbers. Well, if you were, let's say, square rooting 2, or square rooting 1, square rooting 0, square rooting minus 1, you could look at what happens. Square root of 2, that's going to be irrational. Square root of 1, that's going to be just 1, which is natural. Square root of 0 is going to be 0, so that's going to be a whole number. And the square root of negative 1, well, we don't deal with that in our course. It's not a real number, but it is the type of number. It's a complex number, or sometimes called an imaginary number. Now, I don't really like the term complex number because it makes it sound hard and scary for students. But I also don't really like the term real number. Real number implies that, oh, these are the real numbers. The other numbers are fake, poser numbers. And I really think that's pretty judgy to call some numbers real and some numbers imaginary. I mean, all numbers really are made up. They're something that we as humans decided would be useful for counting and for calculating and for doing problem solving in mathematics. And so, square root of 2, it might be irrational, but again, it's very judgmental. There's nothing ridiculous about the square root of 2. You might call someone irrational if you were trying to insult them, but I don't think it's fair to insult the number square root 2. Similar, I don't think it's fair to say, 1 is the most natural number. There are many natural numbers out there, and I think pi is quite natural if you're looking at circles. So it's something to think about in terms of the naming of the numbers. Why would you really call this one complex? Maybe it's not that hard to learn after all. So hopefully you enjoyed this video, and as always, thanks for watching.